Assalamualaikum warahmatullahi wabarakatuh, and very good day. For this video, I would like to present to you the example of solution steps. Alright, for this problem 9.14, let's read the question first. A vertical column of A36 structure steel. Which one is A36 structure steel? This one. So all of this is the vertical column. They give us the yield strength and the ultimate tensile strength of A36 structural steel. Ultimate tensile strength is in between 400 to 500 megapascal, and the size wide is 250 mm. An attachment has been designed to the point shown in the figure. The static load of 80 kilonewton is applied, and the clearance A, which one is A? This one is A, of 156 mm has to be equal or exceeded. So 156 mm. The attachment of 1018 hot rolled steel, ini adalah attachment. This is attachment. Hot rolled steel 1018 to be made from 12 mm plate with well-on bosses when all dimensions are known. So meaning we have to know all the dimensions and the properties first. So specify the weldment. They ask us to specify the weldment, the pattern, the electrode number, the type of weld, the length of weld bed, and the leg size. So the leg size ni usually the H lah. So length of the weld bed, let's say kalau kita weld overall ni, so berapa length dia, overall length, okay. And then electrode number, either it is E60 something or E70 something or E80 something, and then the pattern. Okay, for the solution, because mostly is on the text, so I just use the text in the slide. So for the solution, we have exactly like my previous video. We have to give all the material properties of the weldment parts, the weldment members. Firstly, the column. So which one? The column. The column is, this is the column A36. A36, given in the question the material properties. So the yield strength is 250 megapascal. Ultimate tensile strength is in between 400 to 500 megapascal. Because we want to make the minimum one, take the minimum one, which is the ultimate tensile strength, to the 400 megapascal. So take 400 megapascal. And then the second one is the attachment. The attachment materials to the vertical column. 1018 HR, table A18. Please refer to table A18. Alright, from the table A18 you may get the ultimate tensile strength and the yield strength. Alright, and then use the same methodology to get the permission of shear stress according to AISC code. So table 9.4, in this case, this is the what? The shear stress, and the shear stress, and then we know that for the shear stress, and we have to take 0.3 SUT and 0.4 SY. So which value that we should put for ultimate tensile strength and yield strength? Alright, again use the minimum one. So you put them, allowable shear stress is minimum of 0.3 SUT, minimum 0.4 yield strength. So for the ultimate tensile strength, we take the 400 one. So 400, both of them, vertical column and the attachment material, 400 megapascal the minimum. For the yield strength, we take the lowest one for the attachment, 220 megapascal. Then from both of them, we take 0.4 times 220 lah, 88 megapascal. Now we want to see the decision for the electrode. Okay, so now we don't have the question didn't specify the electrode number, so we have to give assumption or make judgment what is the suitable electrode number. So how to get in the answer, it give us use E6010, right? Why they use E6010? Okay, basically it refers to allowable shear stress, which is 88 megapascal, and then they refer to the table this and table 9.6. Whenever you refer to table 9.6, it says allowable steady loads. So remember, we have the allowable shear stress 88 megapascal, right? So this is allowable shear stress. In our attachment is 88 megapascal. So 88 megapascal basically is lower than 124 megapascal. So the electric code is 60. So they just use 60 as the electrode number. So they just give E6010. So 10 is usually the generic number, so you use E6010. Alright, so after getting E6010, then we want to know what is the ultimate tensile strength and the yield strength. So ultimate tensile strength and the yield strength, we can get it from the table 9.3. So basically, if you don't want to put E6010, you just put E60XX. Yeah, it's still acceptable. So for the E60, you see that you get the value of 427 megapascal for tensile strength, 348 for the yield strength. So you just use that value, bring in the table, your solution sheet, and then put down both of them, and then you make the same 0.3 according to AISI code, 0.3 SUT and 0.4 SY. Then you get the minimum one, you get 128.1 megapascal. So this is the decision for electrode. Okay. All right. How about the decision for allowable shear stress? So allowable we just got for the electrode decision, right? And now what is the decision for allowable shear stress based on what? All the welding members. So welding members, we have 3 welding members. We have the attachment, we have the column, and we have the electrode. And then all of them, the allowable shear stress that we get is 88 megapascal. You have to write it down because it will bring you marks. Okay, it give you mark. Decision for the welding pattern. Now for the welding pattern, right? For the welding pattern, basically it's based on judgment as well. But what does it mean by welding pattern? Okay, welding pattern is actually referring to the pattern. Look, the pattern. So remember the bold line referring to the weldment ataupun the weld area. So if you have straight compared to two side, so better the two side one, right? But if you do have square weld, that would be better and stronger. So that's why in this case they give us suggestion to take pattern square well all around table 9.1 category 5. So in the category 5, and then they choose 150 mm times 150 mm size. Why they take 150 mm? Because we know that D is 150 ni kan, 150 mm. So if you do have 150, here is 150, and here is 150, and here is 150. Alright, that's the first. Just answer the question for so-called part A. How about part B? So part B, they ask question on specify the length L1. Kat mana length L1? This one. Specify length L1. This one. Alright, so we know that L1 is 150 plus A equal to 150 plus 156 equal to 306 mm. How they got 156? This one, A is already 100. A given 156A, and in the question 156, and then we agree that we use square well category 5 in the table 9.1, which is 150. So 150 plus 156, then you get 306. Right, now how about the leg size, which is the H? Okay, so to get the H, we have to calculate based on what? Based on the properties table. So properties table that we can refer in this study is table 9.1 lah. Sebab 9.1 we use category 5. Ingat tak? So the square one category 5 for the area, it's actually 1.414 H B plus D. We know B, we know D, and then we don't know the H. So you get the 424H when you sum up all of them. And then we can calculate the centroid as well. Why we want to know the centroid? Because definitely we want to calculate overall shear stress. Because having all the shear stress calculation, then we can reserve ataupun we can block H. We can get the H expression, and then the H expression can be compared with the area expression of H. Now you get all the primary shear stress exactly like the first video that I presented. You have a look on the primary shear, which is the torsional of according to the y direction. This is the shear force, so we get the F 80,000 because given to us 8 kilonewton. 80 or 80? Yes, 80, sorry. 80 kilonewton, and then divided by 424H, and then you get 188 over H. For the secondary shear, for the category 5, then you get this value JU B plus D power of 3 over 6, and then you put the JU into the second polar moment, then you get the second polar moment of the secondary shear. You get this value, and then you get because of our B equal to D, that's why again secondary shear stress for X and Y are the same. Both of them we get the same, and then you put them in the square root to get the maximum shear stress. So from the maximum shear stress, you get this expression with the H, and then you relate the maximum shear stress to the attachment of 1018 HR stand. Ni berapa? 88 megapascal. Remember that we get this from the attachment or the lower strength for the welding members, 88 megapascal. Then you just compare tau max equal to allowable shear stress for the 1018 HR, and then you can get the H 8.6 mm. Most of the time in mechanical design, when you do the attachment, even in the screw and bolt and nut, you will see that we have to make the nearest run out to the nearest 5. So 8.6, you just decide get to the 9 mm. So from the 9 mm, we get the H, then we can have all the specification for the weldment, for the welding members. So weld pattern, you just write down all around the square weld bed. Electrode E6010, type of the weld fillet. Fillet is always good, especially for the attachment like that. The weld bed length is 150 times 4. Why times 4? Because 150, 150, 150, 150. So basically, you sum up all of them, you get 600 mm, right? And then leg size is 9 mm. Attachment HR 306 mm. Okay, knowing all this specification, then you can make a very good analysis of the welding. Thank you.